Good morning. Welcome back to the value added course on data analysis using Python. Today, we are going to continue our discussion on Numpy Part 2. So, in the previous class, we have discussed about what is Numpy array, how to create the Numpy array, and some of the operations that can be performed on the Numpy array. Today, we are going to continue our discussion on the various operations on Numpy array. So today's agenda is going to be on concatenation of arrays, that is merging of arrays, reshaping of arrays, dimensionality can be changed, splitting arrays, arrays can be split into number of arrays, and various statistical operation on arrays. Concatenation of arrays. Concatenating one-dimensional means appending the sequence one after another. NumPy.concatenate function can be used to concatenate two or more two-dimensional arrays, either row-wise or column-wise. Concatenation means join two or more arrays. We'll see some example. So we have array 1, which is created using NumPy np.array. These two lists are being created as an array. And np.zeros. Using that, a 2 cross 3 0 value array is being created, and these two arrays are being displayed. Array 1, you are going to have some two lists combined into an array. Array 2, 2 rows and 3 columns with zeros. And we see the shape of an array. Array 1 dot shape is 2 comma 2, and array 2 dot shape is 2 comma 3. So when you're going to concatenate in the axis 1, that is row wise, it is possible because both the arrays are having two rows. If you're not going to have the rows matching, we cannot concatenate. So NP concatenate array 1 comma array 2 with axis equal to 1. We are having the result concatenated value of these two. So the first value is having the first row 10 comma 20 followed by two zeros, and the next row is minus 30 comma 40 with three zeros. So this gives you the concatenation of these two. But if you try to concatenate the np dot concatenate array 1 comma array 2, which is without this axis 1, yeah, that is combining it in column wise, you do not have the columns match. Here we have two columns, here we have three columns, so it will give you value error. Reshaping of arrays. Shape of an array can be modified using this reshape function. Reshaping an array cannot be used to change the total number of elements in the array. So you can only change this shape, not the total number of elements. For example, array 3, you are going to have np.arrange 10 comma 22. So we are going to have values from 10 up to 21. So this is what is the content of array 3. So it is a one-dimensional array. So now we can reshape array 3 dot reshape 3 comma 4. The same array we have converted into 3 rows 4 columns. So reshape followed by the number of rows and columns. Dimensionality, if you specify, you can convert it. The same array 3 dot reshape 2 comma 6, it is being converted into 2 rows 6 columns. So reshaping is, we cannot minimize the number of elements, but we can reshape it according to our convenience by specifying the row and column, number of rows and column, without altering the number of elements in the array. Coming to splitting arrays, an array can be split into two or more subarrays. NumPy.split function splits an array along the specified axis. We will see an example. Array 4 we are going to consider, which contains 4 rows, 5 rows and 4 columns. We're going to have 1, 2, 3, 4, 5 rows, each row containing 4 columns. So this array, we are going to split it into a number of possible participants. For example, if you want to specify the splitting of array in 1 comma 3, which means it indicates the row indices on which to split. So we'll have to split on the first row and then on the third row. So the remaining can be stored in another array. For example, this command first comma second comma third equal to numpy split array 4 into 1 comma 3. So you split this array 4 with the parameters 1 comma 3, that is with the first row and third row, and store it in the array named first, second and third. So the first row will be available in the first array, 2 comma 3 will be available in the second array, and the remaining available in the third array. So you can see the result displayed. Array 4 is split into first row and stored in the sub array first. So you display first array, it is going to have the first row alone. And array 4 is split after the first row and up to third row. So our first split up to first row and then up to third row. So the second array will contain row number 2 and row number 3. The remaining rows of the array 4 are stored in the array called third. So with one command, we have split the array 4 into first, second and third by specifying the row indices. So you can specify the row indices with which you want to split the array. And similarly, same, if you are going to specify 1 comma 2 and axis 1. Axis 1 means column wise. So axis 1 gives a column indices along which you are going to split the array. The same array 4 is taken, split array 4 comma 1 comma 2 in axis 1. So you split the first column alone and the second column alone and leave the remaining. So there are 4 columns. So with values, this is the command. First column, second column, third column, numpy split. So this is the command. So the first column is available in first C. The second column is available in second C. The third column is having the column number 3 and 4. So the column wise split can be done by specifying the axis equal to 1. There are some statistical operation on arrays. Numpy provides functions to perform many useful statistical operations on arrays. Let us consider 2 arrays, array A and B. We have some values on array A and similarly we have values in array B also. So the max function finds the maximum element of an array. So max element in one-dimensional array A dot max function will give you the maximum value in A. And similarly, max element in two-dimensional array. This is going to be a two-dimensional array. Maximum value in function will return the maximum value in a two-dimensional array. So whatever may be the dimensionality, the max function will return the maximum value in that particular array. And if axis is equal to 1, it gives column-wise maximum. If axis is equal to 0, it will give you column-wise. So you can find the values row-wise and column-wise. For example, minimum function finds the minimum element in array. You know, array dot minimum will give you the minimum. But when you specify array dot minimum axis 0, it is going to consider the column-wise. So in the column, what is the value? It is going to specify. So minimum value in the row-wise 3, 2 is the minimum value. And sum function finds the sum of all elements in an array. So array A dot sum, it will give sum of all elements in the array. And similarly, B dot sum will give you sum of all elements in the array B. So axis is used to specify the dimension on which the sum is to be made. Here axis 1 means the sum of the elements in first row. So if you specify row wise, you can get it, and similarly you can also column wise. For example, B dot sum axis 1, it is going to give you a row wise sum. The first row total is 9 and the second row total is 6. It is going to specify. And similarly, mean function will give you the average value of an array. So array A dot mean will give you the array value, and similarly B will give you an average value. But you want to find it to row wise and column wise mean, you can specify the axis. So array B dot mean axis 0 will give you column wise, and similarly axis 1 will give you row wise. So the total array average value you can find out, row wise average also you can find out using these two statistical functions. And the last function is the standard deviation function, which can be used with the ND array. So array A dot standard deviation will give you the standard deviation of all the values available in particular array, and similarly for B, and similarly for row-wise standard deviation and column-wise standard deviation and row-wise standard deviation, we can specify axis equal to 0 and 1 and find the standard deviation row-wise and column-wise. So far in this lecture, we have discussed about the various operations on NumPy arrays. We have discussed about concatenating arrays, that is merging of arrays. We have seen about reshaping of arrays. We can change the dimensionality of the array. And the splitting of arrays, we can split a single array into one or more components. And similarly, we have seen statistical operations like minimum, maximum, average, and the standard deviation. So far in these two lectures on NumPy, we have tried to include what are the speciality of this particular NumPy library, which is a third-party library, and how efficient this NumPy library in performing various statistical operations. If we want to use the default Python operation, we can do. But if you want to have increased performance, then we'll have to have use this NumPy library in order to increase the performance. Thank you.